Good afternoon. I'm Karan Sikka from UC San Diego, and today I'll be giving a talk on my work that's titled LOMo, Latent Ordinal Models for Facial Analysis in Videos. And this is a joint work with Gaurav Sharma and Marian Bartlett. So the specific problem that we are trying to target in this work is visual prediction of human facial behavior in sequences. And we want to model the fact that expressions are dynamic events. So we want to take into account both appearance changes and temporal evolution. So we cast our problem as sequence classification with video or weak level labels. And when I say weak labels, it means that the labels inform you about what happened in the video, but they don't give you any information about where it happened. So we propose a loosely structured latent variable model. And the idea is that we want to discover these discriminative sub-events. And we want to jointly learn these event templates as well as the prior on their orderings jointly and in a weakly supervised setting. So our model consists of event templates, which are essentially linear classifiers, and ordering costs, which means that let's say if there are m events, then there are m factorial ordering costs, and we learn these parameters using a L2 regularized hinge laws minimization framework, and we use it, solve it using stochastic gradient descent. And our novelty lies in proposing this scoring function that consists of two parts, and it essentially adds these average sub-event template scores and the ordering cost, and we also put an overlapping constraint so that the model doesn't overfit, and we solve for this scoring function using an approximate greedy forward search. This is a high-level overview of our scoring function. So what our scoring function does is that it takes a video, it scores a video according to different events, and then it gives the final score as sum of the events and the corresponding ordering that has been observed. So we tested our tested our algorithm on 4 data sets, which comprises of both posed and spontaneous facial expressions. 2 of these are expression recognition data sets, CK plus and OILU, and then on UNBC McMaster shoulder pain data set, and finally on Liller non-verbal behavior data set. So to compare to the state-of-the-art approaches, we trained our model on multiple features and fused them using late fusion. And you can see that we got some decent improvements relative to the prior art, especially on UNBC McMaster dataset, which when we compared our algorithm to different multiple instance learning algorithm, we saw good improvements. So the thing that I want to show in this particular slide is the visualization of happy classifier. So we took a classifier that was trained to classify happy expressions, and we ran it on a sample that's a positive happy sample and on a negative sad sample. And the thing that I want to stress here is that the ordering cost that was actually learned for order event 1, where event 1 seems to be corresponding to neutral, 2 to onset, and 3 to apex, was higher as compared to random ordering that was observed in a negative sample. So if you want to know more about our work, and I'll be happy to answer more questions at poster number 31. Thanks.